Historically, the AITutor YouTube channel has been full of A-level maths content. So past papers, stuff like that. And that is because AITutor has historically been a product for A-level maths students. However, we have recently completed and polished off the GCSE Mathematics course on AITutor. It's all there, ready to go. So, in light of that fact, I'm going to start bashing out a load of GCSE videos as well. And I'm going to start off with some past paper solutions because that's the classic, innit? So I'm starting off today with Edexcel, and it's June 2018, paper 1 for the higher students. So it's a non-calculator paper, so my editor will be buzzing because he won't have to do any editing of the calculator shots. Easy times. Let's have a look at question 1. So it says work out 2 1/7 plus 1 1/4. So it's pretty simple. It's mixed numbers, isn't it? Now, the hard thing is adding up these fractions, right? Because there's no common denominator here. So, essentially, 2 1/7 basically means 2 plus 1/7. That's what it is. So then I'm adding that to 1 1/4, which is 1 plus 1/4. So what I can do here is I can actually add the numbers up, and then I can think about the fractions later. So, I mean, 2 add 1 is 3. I think we all know that. And then essentially, all I need to do really is I need to add 1/7 to 1/4. The reason I can't do that really easily is because they've not got the same denominator. So I need to get a common denominator here. And essentially, the easiest way to do it is if you just times these two numbers together, you know that that's going to be a common denominator. Especially when the numbers are small, it don't really matter if you've not found the optimal smallest one, just times them together, mate. So here's what we're going to do, right? So in order to not change the value of these fractions, I need to times both the top and the bottom by the same number. Because if not, if I just times this by 4 and then left that there, I would change the value of the thing. And I'm not allowed to do that, am I? So I need to times this by 4, right? So what I'm going to do is I'm going to do 1 times 4 on the top and then 7 times 4 on the bottom. So I've not actually changed anything, have I? Times by 4 and divided by 4. And then same thing here, but I'm going to multiply everything by 7. So it'll be 1 times 7 over 4 times 7. And now this is going to be a common denominator, isn't it? But we'll get to that in a sec. The 3 is still chilling, that doesn't care. So this is 4 on the top, and then what is 7 times 4? Well, 7 times 2 is 14. So then 14 times 2 is 28. So I get 4 over 28. And then plus 1 times 7 is 7. And then again, 4 times 7, so that's the 28. Now I can add these things together because there's a common denominator, right? So this is going to be 3 plus, and then 4 plus 7 is going to be 11 over 28. So I'm not quite done yet because I am going to need to kind of actually get this together. So in this case, I suppose we've got two options. It can be a mixed number or it could be an improper fraction. Now, because I'm looking at this and we've kind of been given it as mixed numbers, I'm going to keep this as a mixed number. So in other words, I'm kind of doing the opposite of what I did here. 3 plus 11 over 28 is just going to be 3 and 11 28ths. And that is going to be your answer there. Easy. Have a look at part B. Part B says work out 1 1/5 divided by 3/4. Okay, so what I'd like to do now is this 1 1/5. I actually want to express this as a fraction. Because when we're multiplying and dividing fractions, you kind of have to do a lot of the, top times top and all of that stuff. So as a mixed number, it's not really going to work out. So how do I get this mixed number as an improper fraction? Well, if we kind of think about the fact that 1 1/5 is 1 plus 1/5, we need to do the same thing with the common denominator, right? So the common denominator is going to be 5 here because this doesn't even have a bottom. So 1 is the same as 5 over 5. I've still got the 1 over 5, so in total this is 6 over 5. So now let's rewrite what they want us to do. They want us to do 6 over 5, which we know is 1 1/5, divided by 3 over 4. Now, do we remember how to divide fractions? You should, because if I divide by a fraction, all that is the same as is multiplying by that fraction flipped. In other words, this is 6 over 5 multiplied, and then instead of 3 over 4, it's 4 over 3. And now we're laughing, because top times top, bottom times bottom. So 6 times 4 is 24. 5 times 3 is 15. Sick. Can we, do any cancellation at all? I think we can. I believe 3 goes into both of these. So if I did 24 divided by 3, that is 8. 15 divided by 3 is 5. Cool. Now, we want our answer as a mixed number. So this is the correct mathematical answer, but this isn't a mixed number, it's an improper fraction. Improper fraction is basically something that has the numerator, or the number on top, bigger than the number on the bottom. So essentially, I need to split this up into a whole number and then the rest. So in this case, we basically need to go up in multiples of 5, right? So I know that 5 over 5 is 1, and then 10 over 5 is 2, 15 over 5 is 3, etc. But we've not got 10 over 5, we've got 8. So we've got 5, but then we don't have 10, do we? So essentially, this is like 5 lots of 1/5, and then an extra 3 lots of 1/5, isn't it? Because 5 plus 3 is 8. So that is 1, and then I got the 3/5. My answer is going to be 1 and 3/5. Let's see what's popping off for question 2. So we've got a village, right? Number of houses and the number of flats are in the ratio 7 to 4. Let's get a bit of this down. So we've got like house to flat is 7 to 4. And then flats to bungalows is 8 to 5, okay? So this is an absolute classic, right? It's where they have two ratios and they want you to kind of relate them, right? You can see that the only thing in both of these ratios is the flats, isn't it? So that's the key here. It's somehow getting the flats as the bridge, right? To relate the bungalows and the houses. Because here's the thing, right? We're told that there's 50 bungalows and we want to know the houses. So it's like we're here, right? We need to jump over this kind of flats to get to the houses, okay? So we start here, start at bungalows, right? How many bungalows are there? There's 50. So what we could do here is we could say, okay, if there's 50 bungalows, how many flats would there be? Remember with the ratios, like we can times both of the numbers by the same thing and that's still going to be a correct ratio. So we say, okay, well, what do I need to times 5 by to get 50? 10. I just need to do that same thing to the flats. Meaning that if there are 50 bungalows, there are going to be 80, 8 times 10 flats. Sweet. Okay, so I suppose then the question is, right, let's imagine there were 80 flats. How many houses would there be? Because we know there are 80 flats, right? So this is that bridge, isn't it? As soon as I've got 80, I can say, okay, what would be the case for this ratio? So then it's the same thing. I say, okay, well, what do I need to times 4 by to get 80? It's going to be 20, isn't it? Because 80 divided by 4 is 20. So just times the 7 by 20, then you're done. So times them by 20, I would usually times by 10 and then double it. Or double it, then times by 10, whatever you want. So 7 times by 10 is 70. Times that by 2, you get 140. So your answer is going to be 140 houses. Simple as that. Question 3. They absolutely love these type of questions, mate, right? So Renee buys 5 kilos of sweets to sell. She pays a tenner for all the sweets. She puts all of the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. Sells all of the bags of sweets, working at the percentage profit. They love these because you might be looking at this and you're like, mate, way too much information. What is popping off? We need to really go bit by bit, like cash in each bit of information at once, right? So why do I care that there's 5 kilos of sweets initially? Well, I think that's related to this kind of, she puts 250 grams of sweets into each bag. Because if you think about it, 5 kilos is 5,000 grams. Each bag is 250 grams. So I suppose you could ask yourself, how many bags does she actually create from this absolute truckload of sweets? Well, if we do 5,000 divided by 250, we're going to get that answer. In the calculator paper, you would just obviously use your calculator for this. Now, 5,000 and 250 are pretty nice numbers because we're in the non-calculator paper. So these are kind of numbers that you might just be able to see, but essentially kind of 25 and 5, those kind of numbers, regardless of how many zeros are after them. If I multiply this by 2, I'm going to get 500, right? So I noticed that because these are quite nice numbers. So then if I multiply that by 10, 500 times 10, I'm going to get 5,000. Meaning that, putting these together, that's essentially 250 times by 20, isn't it? 250 times 20 is 5,000. Meaning that she gets 20 bags worth of sweets because each bag is 250 grams. So she gets 20 bags here. Okay. She sells each bag for 65p. So how are we going to work out how much, money, how much revenue she gets? Well, we would do the 65p times by 20, right? 20 times over. So 65 times by 20. And again, pretty nice number, isn't it? 20. They're not going to make you do 65 times 38, bit grim. But times by 20, again, we can times by 10 and then times by 2. So what we can do, 65 times 10 is 650. And then I still need to times it by 2. That is going to be 1,300. Now remember, this is pennies, isn't it, right? So what is 1,300 pence in pounds? 13 quid, isn't it? You move the decimal point twice. Okay, so she buys all the sweets for a tenner, sells them for 13 quid. What is going to be her percentage profit? Well, I suppose we then say, okay, well, what is 13 as a percentage of 10? Well, 10 is 100%. You need to add another 30% on, which is £3 to get 13. Therefore, my percentage profit is 30%. And that is all we need to do for question 3. So we got a cycle race across America. It is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles an hour. For the next race across America, he'll cycle for 8 hours a day. Estimate how many days Juanito will take to complete the race. Okay, keyword here, estimate, right? We do not have a calculator. Imagine doing calculations that involve 3,069.25 and 15.12 without a calculator. I cannot. So when you're estimating, we can say, okay, well, what is 3,069.25 really close to? 3,000, isn't it? That makes a lot more sense. That is a number a lot easier to work with. Similar with the 15.12, like pretty close to 15, isn't it, right? Now we're talking. 8, I reckon we can work with 8. 8 is a nice number, okay? So we could ask ourselves the question, well, okay, he travels 15 miles each hour. How many miles does he travel each day? Well, 8 hours a day, 15 miles an hour, 15 times 8. You might know what this is. What you could do is you could do 15 times 10 and then 15 times 2 and take them away from each other, because then you'd be left with 10 minus 2 or 8 lots of 15. So 15 times 10 is easy, isn't it? Because you just stick a 0 on the end. 15 times 2 is also pretty easy because 2 is a small number, so that's 30. And then if I take these away from each other, I'm going to get 15 times 8, which is 120. So every day, Juan travels 120 miles. Sick. How long is it going to take him to travel 3,000 miles? I need to divide, right? So I need to say, what is 3,000 over 120? Now, you could do long division or something like this. Again, because these numbers are quite nice, you can kind of generally see patterns, right? Like 120 times 10 is 1,200. So if I double that, that's 2,400. So that's essentially 20 lots, isn't it? That's 120 times 20. So that's 20 days. And then there's only 600 left. But actually, 120 times 5 is 600, isn't it? Because it's going to be half of this. So it's basically, 20 lots plus another 5 lots. In other words, it's 25. You could have done long division there. That's just me, giving you examples of how nice numbers can work in these non-calculator papers. Essentially, you're actually just timesing. You're not really doing any dividing there, which is nice. So it's 25 days. This is going to be your answer for the first part of this question. Let's have a look at part B. Juan trains for the race. Good on him. The average speed he can cycle at increases. It is now 16.27 miles per hour. How does this affect your answer to part A? Luckily, we don't actually have to do any maths here. So let's think. 16.27 is bigger than 15.12, right? So he's going to be going faster. So if you're going faster but traveling the same distance, it's going to take you less time, isn't it? So the amount of days it's going to take him is going to be less, right? So it's going to decrease. This will decrease the answer to part A as, he is faster. So it will take him less time to cover the distance. Nothing too crazy there. So yeah, the estimation questions can look very scary, when you actually see the numbers, but then as soon as you see that word estimate, it just gives you a nice little out. 5. Here is a solid square-based pyramid, VAPKD. The base of the pyramid is a square of side 6. The height of the pyramid is 4. M is the midpoint of BC and VM is 5. Okay, draw an accurate front elevation of the pyramid from the direction of the arrow. Let's get this diagram up here. What is the front elevation, right? Well, it is exactly this. It's the front view. In other words, right, you're stood here at the front of the pyramid. You're just looking straight at it. What can you see? First of all, it's only actually really 2 dimensions that you can see, isn't it? Like your view is just kind of going out like this. If I'm stood here, all I'm going to be able to see is a triangle, right? I can't see how far back it is. I don't know. It could, I'm just seeing a triangle. It could stop there. It could go on for miles. All I can see is the fact that it's 4 centimeters tall. I can see that. And I can see how wide it is. So I'm basically just looking at this triangle going this, right? So all I need to do here is super simple, right? Basically, I need to draw a line that's 6 centimeters. Each one of these squares is 6, right? That would be 6 right there. And then I know that it's 4, right? So basically go to the middle and go 1, 2, 3, 4. And it is genuinely as simple as that. That's it. Because that's all you can see. Those 2 pieces of information. 6 wide, 4 tall. Sick. Part B says work out the total surface area of the pyramid. Okay, all we need to do here is just kind of be careful of all of the things that we're, taking account of. So essentially there's the bit at the bottom, right? So let's call that 1. There's this face here. Why don't we call that 2? Then there's a face kind of at the back. We can call that 3 all the way back there. And then there's this face at the side. We can call that 4. Right. So how are we going to do this? There's a few things popping off. So the first thing that I'm noting is we've kind of almost got this nice little right angle triangle kind of going on here, haven't we? If we were to look at this, that's a right angle triangle. And I think that is going to let us get, all of the information that we need maybe. So what I am seeing is that this goes straight to the middle, okay? And now we know that we have 6 centimeters here. So this is halfway through, so this is going to be 3. And it turns out that you also could have got that from doing Pythagoras on this triangle, because we have the hypotenuse as 5, and then we have the 4 and the 3. So that would have worked out. Okay, what do we need to know here? Well, we need to know the heights and widths of these triangles, because the area of a triangle is a half base times height. So a half BH. So if we think about kind of this triangle here, now, we know that this is a square, actually. So all of these triangles are actually going to be the same, aren't they? Because each side has a length of 6, meaning that every single one of these triangles, it has a height of 5. And the height isn't 4, because if you think about this triangle, it's actually slanted. So this triangle's on a slant. If you were to just pull it straight like that, so the tip of it is just facing up, it would have a height of 5. And that is this slanted height. So each triangle has a half, and then the base is 6. And then the height is 5. So what's this going to be? Well, a half times 6 is 3. So that's 3 times 5. Each triangle has an area of 15 centimeters squared. There are 4 triangles, aren't they? So 4 times 15, and that's going to be 60. So we've got all of the triangles. The only thing left is this 1, isn't it? And that is basically just a square. Well, the area of that is just going to be 6 times 6, because it's a square of length 6. So that is 36. So the total area is going to be 60 plus 36, which is 96. What are the units? Centimeters squared. So question 6 looks like a bit of a funky one. It doesn't really look like anything really normal that we just know how to reel off. It looks like we're going to have to do a bit of thinking, unfortunately. So we've got a pattern, right? 4 identical squares. That is super important. So each one of these squares is identical, and it is a square, meaning the length and the height are the same. I said length and height. You know what I mean. Point A has coordinates 6, 7. Point B has coordinates 38, 36. Point C is marked on the diagram, and work out its coordinates. Okay, there's quite a lot popping off here, isn't there? Something that I do know is if you look at either A or B, it doesn't matter, just lengthways, not heightways, so like along the x-axis, C is 2 squares away from them, just in terms of the x, right? Because, if I go 1 square across, 2 squares across from A, I get to C, don't I? That is important, because here's the thing. If I just know the height and the length of each square, then I could work out at least the x coordinate of C, right? Because I can say, I know what the x coordinate of A is. If I add one square, add another square, I get the x coordinate of C. So we can start off by trying to work out the length and the height of each square. How are we going to do that? Have a look lengthways again. 1 square, 2 square, 3 square, 4 square, and I'm at B, aren't I? So here's the thing, there are 4 squares between A and B lengthways. So what is the coordinate? The x coordinate of B is 38. The x coordinate of A is 6. So what is the length of all 4 of these squares put together? It's going to be the difference between 6 and 38, which is 32. And that is perfectly split in quarters, right? In 4 between these 4 identical squares. So the width of each square is just 32 divided by 4, which is 8. This is good because it's a square, so we know that the width is 8, but the height is 8 as well. So I can easily work out the x-coordinate of this C, because if I start at the x-coordinate of A, which is 6, add 8, right? So that would get me there. Add another 8, that gets me there, doesn't it? So what is 6 add 8 add 8? Well, 8 add 8 is 16. Add another 6, I get 22. So the x-coordinate of C is 22 because it is 2 squares away from A and 2 away from B. The y-coordinate isn't that simple though, is it? Because it's actually just kind of at a random point between these squares. They cross over. And it doesn't, for example, say, oh, it's in the middle. If it said, oh, it's in the middle, it'd be quite easy to work out. You'd kind of just add half a square. But it doesn't say that. It just does that. So, like, how are we going to find this out? It's a bit strange, isn't it? So, here's the thing. Look at what I was doing here. Imagine I was to do this to just height ways. I almost, I add this here. I go up 1. What would that get me to? Well, that's 7. Add another 8. That would get me to 15. And then I kind of add another 1 here, right? Add another square. What would that get me to? Well, is it adding 8 again? So that'll get me to 23. So I'm here at this point. Now, this is the tough thing, isn't it? Because aside from this, they don't overlap. Like this one perfectly hits at the corners. This one perfectly hits at the corners. But these overlap. So I want you to imagine for a second that I just took these 2 squares and just pulled them both up so that it was on the corner. In other words, so it basically looked like this and then this, if that makes sense, right? Because so we basically say, look, if they were all just stacked perfectly corner to corner, and then B would almost go up, right? Where would B go up to? And you'll see where I'm coming from. So in other words, we would have to add 1 more square here, add another 8, so that'd get me to 31. And then go 1 more square up here, and that would get me to this. So add another 8 to that, that would get me to 39. So my new, imaginary B, right? I wrote B there, would be the x-coordinate wouldn't change because I've not done anything, this way. So that would be 39. But the new coordinate would be 39, right? So 38, 39 in my imaginary, okay? So what is the movement that I have done here? The movement that I have done is just the difference between this. So we can see that I have brought B up by 3 on the y, haven't I? But here's the thing. Imagine I was to actually just undo this, right? Imagine I was to go back down now to C, right down here. Remember, I went up by 3. So if I was to go back down to C, well, I've gone down by 3. The difference between this point and this point right here is 3, isn't it? Therefore, I can tell you exactly what, where C is going to be at this point. If I know that this is 3, it's super easy for me to work out, isn't it? Because I know that this is 23 here, up on the y-axis. Take 3 away, I get 20, don't I? So, the coordinates of C are going to be 22, 20. So, the x-coordinate was quite easy in this one. The y was weird. There were a few different ways that you could have looked at this. That is the way that I find, well, the easiest for me just seeing this question for the first time. But maybe watch this video a few times and have a bit of a think about that if that still doesn't make sense, because I would say that that is actually a pretty tough question for question 6. Question 7. Shape T is reflected in the line x equals -1 to give shape R. Shape R is reflected in the line y equals -2 to give shape S. Let's grab the single transformation that will map shape T to the shape S. Super, super common, this question. Let's get this grid up, right? So we've been given shape T, but not R or S. What we're going to need to do, get them down, right? So we have a bit of a path, right? T goes on to R, then R goes on to S. Let's get that down before we start thinking about the last bit, about the single transformation. So it's a couple of reflections, right? You need to draw the reflection line first, and then you can kind of get the shape, right? So x equals -1 is this line here. So how do I reflect this shape T? Well, look at each of these vertices, right? Each corner. And then say, okay, what do I need to do to get to the mirror or the reflection line? I need to go 1, 2, and then I'm there. Just do that again, right? So if it takes me 2 to get here, I just need to do it again. So go another 2. So that point would go there. Do the same with all of them. So this one, what do I need to do? I need to go 1, 2, 3, 4, do it again. So 1, 2, 3, 4 takes me there. You can probably guess where the other one's going to be, but just so you're sure, what do I need to do? I need to go 1, 2, 3 to the left, do it again. 1, 2, 3, and this gets me a triangle. So this is shape R, I believe they call it. Cool, so we got shape R, rinse and repeat. This is now reflected in the line y equals -2 to give shape S. So get the line y equals -2 down, that is down here. Exactly the same thing. So what I'm going to do is I'm going to say, okay, to get from here to the mirror, I need to go 1, 2, 3 down. So do it again. 1, 2, 3. That gets me there. This one, 1, 2, 3. So 1, 2, 3. This one, 1, 2, 3, 4, 5. So I need to go 1, 2, 3, 4, 5. And you could see, as it should be, it's flipped round. It's been reflected. It actually got flipped around there as well, but it just happens to be symmetrical around that line, so you can't tell. But it's been flipped twice here. So this is shape S, okay? So quickly, let's just think about the journey of each of these vertices, right? So I'm going to label one of them in yellow. Why not? So this tip, right? This one here went to there, which then actually went all the way down here. Let's go one in blue. Why not? This one here. Now, let's have a think about this. This did not go to that there. It actually went to this. And then this one then went here. So you got your blues there. And then let's have a green. So this, which is obviously it's the only one left now, but this then went to here, then went to here. Cool. So we essentially now forget about all of this. We only want to care about T and S in this case. Now, so you know what I'm even going to do? I'm just going to get rid of these so everything's quite simple for you. So I just can't talk anymore. We need to work out, right, what transformation in a single transformation takes me from T to S. So it's not a translation, is it, where you just move it, because it's been flipped, right? So it's definitely, I can't just pick that up and move it to S. There's going to need to be some turning. It's not a reflection, is it? Because, for example, if this was down here, right underneath T, it could have been a reflection. But because it's kind of off on an angle, but it's actually kind of just been flipped, it's going to have to be a rotation here. Now, one of the really useful things that we can do to find the center of rotation is all we need to do, and this is why I've kind of joined up these vertices, is connect these vertices and you're going to see something happen. If I connect all of these vertices, what is the common theme here? They all intersect at this very point here. So that is the center of rotation. So it's a rotation. I know the center. All I need is the angle now. But if you think about it, this is perfectly flipped around, right? This was pointing upwards. Now it's pointed downwards. So that's basically just a half turn. In other words, 180 degrees. So this is going to be a rotation. Now, interestingly, with rotations, you need to specify if it's anti-clockwise or clockwise. But in the case of 180 degrees, they're actually both the same, aren't they? Because if I stood here and I flip, I'm not going to spin around on my chair. But if I go 180 degrees one way and then go 180 degrees the other way, I actually end up in the same spot. So I will write clockwise, for example, but just to let the examiner know, right, that I know that I need to specify the direction, but it turns out in 180 degrees, you could get away without doing it. So let's say it's a rotation clockwise by 180 degrees. And then with the center of rotation, and then it's going to be the coordinates of this point, which is going to be -1, -2. So I will give you a bit of a hint. Most of the time when we have multiple transformations and then they say describe it with a single one, it's pretty much going to be a rotation. So remember this tactic here and you will be laughing. Question 8, what we got? The perimeter of a right angle triangle is 72. The lengths of its sides are in the ratio 3 to 4 to 5. Work out the area of the triangle. Okay, so we've got a couple of things popping off here, haven't we? We've got some right angle triangle, which is kind of making me think, like geometry, shapes, all of that stuff. But then they're throwing in a bit of ratio as well. So I would actually say that this is primarily a ratios question. Because essentially this is kind of a dividing quantities question in disguise. So what do I mean by dividing quantities, right? Imagine those questions where they're like, Alice and Bob share a tenner in the ratio 4 to 1 or something like that, right? And then what you do is you kind of split up that tenner into 4 plus 1, so 5 chunks, and you say how much is each chunk. So for example, I would add the 4 to 1, get 5, and I say, okay, I've got 5 chunks, and then imagine they have an equal size, and then the whole thing is a tenner. So how much is each chunk worth? Well, it's going to be 2 quid, right? So then the ratio 4 to 1, Alice is going to get 4 of these chunks, so £8, and Bob is going to get 1 of them, so £2. This is exactly what we're doing here, because if you think about it, the perimeter of a triangle is going to be, whatever this side is, plus whatever this side is, plus whatever this side is. So in total, they have 72, right? So the ratio here is 3 to 4 to 5. So here's what we do. We add these things up to work out how many chunks there are. So 3 plus 4 plus 5. 3 plus 4 is 7. Add another 5, I get 12. Okay, so I'm splitting up my 72 pounds or centimetres or whatever pieces of chocolate into 12 equal chunks. How big is a chunk going to be? Well, 72 over 12 is 6, okay? Because, 12 times 5 is 60. Add another 12, you get 72. Okay, so each chunk is worth 6. But, one of the sides has 3 of the chunks, one has 4, one has 5. So what I can do here is I can just individually multiply them all. So if I was to say, 3 times 6, 4 times 6, and 5 times 6, that's going to get me each of the side lengths. So 3 times 6 is 18. I wrote 5 there, and I meant to write 6. 4 times 6 is 24. And 5 times 6 is 30. Okay, so the longest one is always going to be this hypotenuse, right? So I'm going to have a 30 there, and then it doesn't matter. This is just a sketch. Between them, we're going to have an 18 and a 24. Okay, so we know the sides of this triangle, and if you were to add these together, you would get 72, I hope, right? So we now want to work out the area. But in this case, it's actually quite simple because we now just have a triangle. We know that the area of a triangle, as we did in the other question, is a half base times height. So quite simply, I just do a half times 18 times 24. And now I suppose we need to do a bit of maths, right? So we don't have a calculator here, so it's whichever way you find this easiest, right? Let's put this half into the 24. So I essentially need to do 18 times 12 here. And then it's up to you. So I like to kind of look at numbers that are easy to multiply by. So things like times and something by 10 is really easy, right? Because you just add a 0. So here, right, if I was to do 18 times 10, all I need to do is add another 2 lots of 18. And I think that's probably the easiest way to do this, right? So 18 times 10 is quite simple. That's 180. 18 times 2 is quite easy to do. It's just doubling it. It's 36. So now what do I do? Okay, well, 180 add 20 is 200. I need to add another 16. So it's going to be 216. Am I done? Probably not, because I just want to give some units. Centimetres squared. Now, to be fair, they help you out because in the kind of answer space, they actually write centimetres squared there. But if they didn't, you would have to include those units to get the full marks. Question 9, we got indices. So if you're on AITutor, you know your indices laws, and it's going to be really easy to just bash these out, okay? So I'm going to be quick here. The first part, a power of a half is a square root, okay? So essentially, this is just the square root of 36, which is 6. Boom, 1 mark. Part B. Well, super simple, right? Anything to the power of 0 is 1. Boom, indices laws. You should know this. Oh, let's get this under a minute. 27 to the minus 2 over 3. Okay, this won't be under a minute. There's basically 3 things we need to do here, okay? So, first thing is, if I have a minus, that is essentially just the same as 1 divided by, and then whatever this thing is without the minus. Which means that this is just going to be 1 over, and then this whole thing, but without the minus. So, 27 to the 2 over 3. Cool. So now we say, what's 27 to the 2 over 3? The 2 things we need to consider are the 2 and the 3. So when we have a fraction, start at the bottom, okay? So what I mean by that is I'm going to split this up as 27 to the 3rd, and then whatever that happens to be squared, okay? Because that is an indices law. That is basically saying that, if I have 2 over 3, that is the same as 2 times a 3rd. So that's the same as like doing one of the powers and then the other. You could do it the other way. However, if I was to do 27 squared, I'd get some crazy big number. Then I'd have to do that to the 3rd. It's going to be really difficult. That's why I say start at the bottom, because you're going to get nice small numbers. So 27 to the 3rd is the same as the cube root of 27, which happens to be 3. That's why it's so much easier to go down here, because now I just have to do 3 squared, which is 9. So the answer here is 1 over 9. Question 10 is throwing down the stats. So here we go. So we've got the height of 80 girls, and they've given us a load of kind of these summary statistics, so like the quartiles and that stuff. Basically the stuff that you need to draw a box plot. So we've got the least height, the greatest height, the quartiles, and the median, which is a quartile. And then we just want to draw a box plot. Okay, so let's get this grid up. This is quite easy, actually. The reason is we don't need to calculate any of the things we need, right? We have exactly the 5 lines that we need. So basically what happens with a box plot is the least and the greatest height, so these kind of edges like this. Then there's the lines, and then there's a box in the middle with the quartiles. And we've been given all of this information. So the least height is 133. So that is going to be 1, 2, 3 away from here. So let's do a line here. The greatest height is 170, which is going to be here. And then we're going to have a box in the middle with the quartiles. So the lower quartile is 145, and the upper is 157. So I'm going to do a rectangle that encapsulating those 2 values. So 145 is going to be this here. And then 157 is going to be 1, 2, 3 away from that. We're then going to have lines just taking us here. We can see a box emerging. Is there anything else? Yes, I need to put the median. The median is going to be inside this box. It's just going to be a line. So the median is 151. So I'm going to do a line at 151, and that is my box plot. So we're going to have, least value, lower quartile, median, upper quartile, greatest value. And that is why this question is quite easy, because they've given you all of that information straight away. Part B says work out an estimate for the number of girls with a height between 133 and 157. Okay, so 133 is the least value, isn't it? And 157 is the upper quartile. So, what is the kind of definition of the upper quartile? The upper quartile is the value. Well, the median is the value such that 50% of the girls are smaller than that, 50% are taller than that. The upper quartile is 75% of the girls are smaller than that, 25% are taller than that, okay? And it says an estimate for the number of these girls with a height between, so look at the bounds that they want here. They want between 133 and 157. But we know that that's exactly the smallest and the upper quartile, meaning that I know that 75% of the girls must lie in this bound, right? So basically, I just need to work out the total number of girls and then 75% of them. So the total number of girls are 80. To work out 75% of those, I just need to times it by 0.75, or 3/4. 1/4 of 80 is 20, so 3 of those quarters is going to be 60 girls, and that is going to be the answer. Let's have a look at question 11. So it's starting to get a bit grim now, isn't it? A and B are points on a circle centre O. BC is a tangent. AOC is a straight line. ABO is X, and we want the size of the angle ACB in terms of X. Okay, let's get the diagram up here. So let's kind of at least get what they have on this diagram. We're told that ABO is X. So ABO is this here. So if I was to draw a line from B to O, I am told that this is X. Cool. Okay. So what I'm going to do here, it says give reasons for each stage of your working. I'm not going to write absolutely everything down here, but I am going to talk about it and put it on the diagram. So I think that should be enough for you to kind of get what I'm on with here. Okay. So let's look at this triangle first of all. OB, that's a radius, isn't it? Because O is the centre and B is a point on the edge of the circle. But OA is also a radius because A is a point on the edge of the circle. So if you were to think of this triangle, it's actually isosceles, isn't it? Because OB and OA are the same length. What that means is this angle must be the same as this angle. There's no other way. Isosceles triangle, right? 2 same lengths, 2 same angles. Okay, well, therefore, this angle, we're going to be able to work it out, aren't we? Because, if the total triangle is 180, and I've got 2 x's, this is just going to be 180 minus 2x. Let's label it here because I'm running out of space. So that's 180 minus 2x. Okay, what is the final thing that we want? The final thing that we want is ACB. In other words, this here. This is my final goal, okay? So if I almost keep going this way until I get angles relevant to this triangle here, we should be okay. This is a straight line, isn't it? So the total angles in a straight line add up to 180. If this is 180 minus 2x, what does this need to be to make this whole line 180? Well, it needs to be 2x, doesn't it? Because 180 minus 2x plus 2x is 180. Cool, okay, so we've got 2x here. If only we knew this, we'd be sorted, wouldn't we? Well, this is where another circle theorem comes in. So OB is a radius and BC is a tangent. Now you should know that a radius and a tangent are always perpendicular. Therefore, this angle is a right angle, which we know is 90 degrees. So at this point, we are laughing because OBC is a triangle. It adds up to 180, okay? And what have we got? We've got 90 here. So if I do 180 minus the 90 minus this angle, that is going to get me my angle ACB. So to simplify this, 180 minus 90 is 90, and then minus the 2x is the angle ACB. Question 12. Prove that a square of an odd number is always one more than a multiple of 4. Okay, this is a proof question, and I want to give a public service announcement, so listen. Please stop just putting in numbers and thinking that's a proof. So if it says prove that the square of an odd number is one more than a multiple of 4, and I say, okay, 3 is odd, square that, I get 9, it's 1 more than 8, done. No, this is not how you prove things. Because in order to prove this, I need to prove that it is true for every single odd number in existence. And I'll give you a hint, there's infinite amount of them. Meaning that if I was to do this, it would take me an infinite amount of time. So stop it, okay? You cannot prove things by just putting in certain numbers. That's not how proofs work. The only way that I'm going to prove this for every odd number, no matter what, is by speaking in general terms. And the way I do that is with algebra, okay? Because if I say, okay, you know what? Let's find the general representation of an odd number in terms of algebra. If I can then prove this thing in terms of algebra, then it's not going to matter which odd number. Every single one is going to abide by this rule. What do I mean by that? What is a general way to write an odd number? Any odd number? Well, what's the general way to write an even number, first of all, okay? An even number is a number that can be expressed as 2 times by another number, right? All even numbers are divisible by 2. So for an even number, I can write that as 2n, where n is an integer, a whole number, okay? So for an odd number, that's just going to be 1 away from that even number. So 2n plus 1 is the general representation of an odd number, where n is a whole number. And any odd number in the world can be expressed like this. You just change the value of n. So n is 0, n is 1, n is 2, n is 3, n is 4. 2n plus 1 is always going to be an odd number. So if I can show that this statement here, prove that the square of an odd number, blah, 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 works on this algebraic construct, then it's going to work for any odd number. So let's have a think about it. This is my odd number, and I want the square of it. Well, let's square it, right? This is where your algebra comes in. So this is why it's confusing, because they're looking at this and they're thinking, you know, numbers, but in reality we use algebra to prove it. So it can be confusing. So the algebra that we're going to have to do now is multiply out these brackets, right? So if I have 2n plus 1, 2n plus 1, let's see what we get. So if I do 2n times 2n, that's going to be 4n squared. If I do 2n times 1, that's 2n. 1 times 2n is 2n. 1 times 1 is 1. Let's simplify this. This is going to be 4n squared plus 4n plus 1. Now, we want to show that this is 1 more than a multiple of 4, okay? So if I can express this as some multiple of 4 plus 1, that proves it, doesn't it? So look at this. I can take a factor of 4, not out of everything, but out of these first two terms. So if I was to do that, it's going to be 4, and then n squared plus 1, and then plus 1. This is the end of my proof. Why? Because I don't care what n squared plus 1 is. It can be whatever it wants. I know that once I multiply it by 4, it's going to be a multiple of 4. So here I've got my multiple of 4, and then I've got plus 1 on the end. So it's going to be some multiple of 4, I don't know what it is, I don't care, plus 1. And it doesn't matter what n is. If n is 1, this is going to work. If n is 467, it's going to work. If n is 14,000,008,000,008, it's going to work. And that is how algebraic proof works. 13. Root 5 times root 8 plus root 18 can be written in the form a root 10 where a is an integer. Find the value of a. Okay, so surds, right? Let's write out what we have and then kind of see what we can do. So root 8, root 18, and then they're all being multiplied. Let's have a think here. So I think the way to do this would be to multiply each of these surds, you know, in the bracket by this root 5, right? So when I multiply surds, you know, like root a times root b, that is the same as multiplying those numbers just inside one surd. So in this case, this would be the square root of 5 times 8. And then this would be the square root of 5 times 18. We know how to work these numbers out. 5 times 8 is 40. So this is root 40 plus root, and then 5 times 18. Okay, well 10 times 18 is 180. Divide that by 2, you get 90. Okay, that's the first skill. The second skill is looking at a surd with a relatively big number and seeing if we can split it up at all. What you generally want to look for is factors of that number where one of them is square. That's the important thing, because having a square factor, you can pull it out of the surd. And I'll show you how now. So I'm noticing 4 here. 4 is a square number. So this is the same as the square root of 4 times 10. Similar vibe here actually, 9, right, is also a square number. So that's 9 times 10. What we can therefore do is kind of the opposite of what we did here, okay? So this is the same as the square root of 4 times the square root of 10. I'm pulling this surd apart now. Similar thing here. This is the square root of 9 times the square root of 10. Why is this useful? Because the square root of 4 and the square root of 9 are just normal numbers, right? Square root of 4 is 2, so that's 2 root 10 here. Square root of 9 is 3, so this is 3 root 10, and this is where the magic happens. We say, these are both root 10, so I've got 2 lots of root 10, added to 3 lots of root 10. That is just going to be 5 lots of root 10. Question 14, we got some inverse proportion. So y is inversely proportional to d squared, d is directly proportional to x squared. So there's 3 variables going on here, so it's pretty difficult, right? It's all about formulas, okay? So we need to convert the sentence y is inversely proportional to d squared into a formula. And that formula is y equals k, which is this constant of proportionality, which we're going to eventually work out. And then in the case of inversely proportional, it's divided by. So divided by d squared. So what we need to now do is get k. So we're told that when d is 10, y is 4, so we're going to sub those in, okay? So if y is 4, I'm going to get 4 equals k over d squared, 10 squared. Okay, multiply by the 10 squared, I get 4 times 10 squared equals k. 10 squared is 100, so 4 times 10 squared is 400. That gets me k is 400. Therefore, y is equal to 400 over d squared. Let's keep this for later. Now, we do the same kind of thing with what we have for the next bit that relates d and x. So we're then told, let's keep this here actually, we are then told that d is directly proportional to x squared. So inversely proportional divided by, directly proportional times by. So d is k times by x squared. Now, if you want to be super pedantic, you might say, well, wait a minute, wasn't k this thing over here? Technically, you could call it a different letter, or you could be kind of posh and like call this k1 and k2. Realistically, at GCSE, it doesn't matter. No examiner at GCSE is going to even bat an eyelid that you use k again, so don't worry about that. Essentially, we do the exact same thing, right? When x is 2, d is 24, okay? So 24 is going to equal k2 times by 2 squared, right? So, because x is 2. What is 2 squared? It's 4. So I get 4k2 equals 24. Divide by 4, and I'm going to get k2 is 24 over 4, which is 6. Okay, what does that tell us? That tells us that d is equal to 6x squared. So with these two pieces of information, I am now going to try and relate x and y. So it says find a formula for y in terms of x. So what I'm going to do is I'm going to grab y, which we know to be 400 over d squared, but then I say, I don't care about d anymore, but d is 6x squared. So I'm just going to take this and inject it into that bit. So instead of d squared, I'm going to get 6x squared, right? So what's this going to be? 400 on top. 6 squared is 36. X squared squared is x to the 4. We actually have to multiply these powers here. We now cancel. So I think the easiest way that I cancel is I just look for factors of 2, right? If they're both even, just keep dividing them by 2. You know, if you're cleverer than me, you might be able to find like a better factor, and you say, they both 4 goes into both of them, whatever. Just go for 2s, right? It's simple. So 400 over 2 is 200. 36 over 2 is 18. We can go again because they're both even. 200 over 2 is 100. 18 over 2 is 9. Do we have any other common factors? I don't think we do. Like, factors of 9 are basically 3. 3 doesn't go into 100. So I'm happy with my final answer as y is 100 over 9x to the 4. Getting through the good stuff now. So the first part of question 15, it says factorize a squared minus b squared. Now, I do not need to tell you that this is difference of 2 squares. You should be able to see this. If not, go to AITutor, right? So a squared minus b squared, I'm not going to talk about this much, but it's a plus b times a minus b. This is called the difference of 2 squares. Simple mark. Okay, part B. Hence or otherwise simplify fully that thing that looks absolutely disgusting. The most important word here is hence. Nothing else matters, right? Hence. What does the word hence mean? It means use the thing that you have just done. In other words, we are going to be using this thing here to solve this or simplify this. So how do we do that? Look at what we have. We've got something squared, so x squared plus 4 squared, and then minus some other thing squared. So if you compare what we have, we essentially, the a, right, is my x squared plus 4, a squared, x squared plus 4 squared, and then the b is the x squared minus 2, right? So this thing here is this, and this is this thing here. In other words, I can go straight to this. I can say, okay, well, this thing here, if this is my a and b, is going to be a plus b times a minus b. In other words, it's going to be a plus b, so this is my new a. So it's going to be x squared plus 4 plus b, so plus x squared minus 2. And then it's going to be a x squared plus 4 minus x squared minus 2. But remember, I'm minus x squared minus 2, so I need a bracket here, because I'm taking away the whole thing. If I didn't have the bracket, that would be incorrect. So now I just simplify, and I'm hoping it's going to get nice, right? So what have we got in this first bracket? We've got 2 lots of x squared. Plus 4 minus 2 is going to be plus 2. And then what have we got here? Well, this is nice, because I've got x squared, but then that cancels out with that. I've got 4 and then minus minus 2. Minus minus becomes a plus, so I've got 4 add 2, which is going to be 6. So now I can just multiply this 6 here. So 6 times 2x squared is 12x squared. 6 times 2 is 12. And that is simplified a lot. So question 16 is looking pretty grim. Okay, so we've got red counters, blue counters, and purple counters in a bag. Right, so we've got the reds, the blues, and the purples. Sick. What else do we know? The ratio of the number of red counters to the number of blues is 3 to 17. Okay, so red to blue, 3 to 17. We're going to have to use that at some point. Sam takes a random counter from the back. The probability that the counter is purple is 0.2. Okay, so if we're thinking of kind of probabilities here, we've got 0.2 here. Work out the probability that Sam takes a red counter. Right. So obviously there's 3 different colours, so that's quite confusing. The ratio, we've only been given it, regarding 2 of them, the reds and the blues. But we are told something about the purple, and that's that the probability is 0.2. So think about probability for a second. There's only reds, blues, and purples in the bag. So what should the probability of all of these 3 add up to? Well, 1. Probabilities add up to 1, right, if they cover all the bases. So if this is 0.2, then we know that the probability of red and the blues must be 0.8, okay? So this is actually another one of those kind of dividing quantities questions that are hidden, kind of hidden. Because all that's going on now is I've got 0.8, and I need to split that between the red and the blue, but I have the ratio of red and blue here. It's 3 to 17. So what do we do when we're kind of trying to split that? We need to add these 2 numbers together to find out how many parts there are. So if I did 3 plus 17, I get 20. So what I now need to do is split this 0.8 up into 20 separate parts. So 0.8 divided by 20 might look kind of grim, but again, 20 is a pretty nice number, because if I divide by 10, which just moves the decimal, so 0.08, and then all I need to do is divide by 2. So this is going to be 0.04. So that's one of the parts. Red has 3 of them, blue has 17 of them. Okay, so 3 times by 0.04 is going to be the red, right? So what's that going to be? So essentially 4 times 3 is 12, right? So you can just shift the decimal point, and this is going to be 0.12. So that's the red. And then the blue is going to be 17 times this 0.04, which might be a bit grim, but when you actually think of it, we know that together red and blue make 0.8. So another way of looking at this is you could do, okay, well, I now know that red is 0.12. So if I just take that from the 0.8, what's that going to get me? That might be simpler. Take off the 0.1, I get 0.7, and then take off the 0.02, I'm just going to get that 0.6, basically. So that is my probability table. Blue is obviously the likely choice, but the final, you know what, I didn't even need to do that, because I actually just said work out the probability that Sam takes a red counter. So you know what, forget the last bit, I mean, it's not a bad thing to do, but your final answer is just going to be 0.12. Question 17. Simplify fully. Oh, here we go. Right, 3x squared minus 8x minus 3. It's about to get pretty dense. Over 2x squared minus 6x. The name of the game is factorization. And the reason is when we have common factors on the top and the bottom, we cancel them. That is what they're always after here. The bottom looks a bit easier to factorize, and that's because we can just take out a common factor without having to deal with multiple brackets. What's the highest common factor here? In terms of numbers, it's 2. And in terms of algebra, it's x. So I can take a 2x out of here. And then I say, well, what would I need to multiply 2x by to get 2x squared? Just an x. What do I need to multiply 2x by to get 6x? Just a 3. So that's the bottom factorised. Let's have a look at the top. Now, this is going to be grimmer. It's going to be grimmer. So we're going to have 2 brackets, okay? The terms here are going to be 3x and x. The reason is that is the only way to multiply 2 things together like that to get this 3x squared, because 3 is a prime number. If it was something like 4, it'd be a bit different because you might have more options. But we've got 3x and x. Now, there's a few ways of looking at this. The first thing is that generally, because we're doing a question where they're asking for simplifications, I assume that one of the brackets is going to be x minus 3. So then that cancels and it's all nice. So I'm thinking about that. And then the other thing, now there is a longer format, a longer method for factorising quadratics that look like this, that have a number in front of the x squared. I'm not going to go through the whole method now because I'm more focused on getting this done, an exam technique. So here's what I would do. I would say, you know what, that's probably going to be x minus 3. Would that work out? Well, I think it would. The number I want to look at here is this. Because no matter what the numbers here are, the numbers on the end have to multiply together to make minus 3. If that was the case and this was a minus 3, what would this have to be? Well, what do we need to times minus 3 by to get minus 3? 1, right? So I can now check to see if this works, right? So I can now maybe go, okay, 3x squared, let's just on the side, let's just try and, sort this out. That's going to be a 3x squared. That's going to be a minus 9x. That's going to be a plus x. That's going to be a minus 3, minus 9. That works. That works. So you can see that was maybe a bit cheeky there. That was kind of, the exam technique. But it's only going to simplify if one of the brackets are the same, right? So at this point, we're good. That cancels. And I'm going to be left with 3x plus 1 over 2x, which is a lot nicer than that. 18. Here is a graph of y equals sine x for x between minus 180 and 180. So this familiar trig function, right? On the grid, sketch the graph of y equals sine x minus 2 for that same range in x values. Okay, let's get this grid up. So they've given us y equals sine x. Why? What is the relation between y equals sine x and the thing that we want to sketch? The only difference is we have exactly what they have, but then we just take away 2. So you should be familiar with your graph transformations. But basically, if I just have a function and then kind of outside of that function, I just add or take away a number, what that corresponds to is a shift in the y-axis. Because think about it. Here we have y equals and basically just 2 less than what they have. They have sine x, I have sine x, and then I take 2 away from it. So all I'm doing is I'm taking 2 away from every single one of the y-coordinates. So this is going to have exactly the same shape as what they have. It's just going to be shifted or translated, right? So if we were to almost copy the shape that they have, all we need to do is we need to pick it up and move it around, right? So for example, if it was plus 2, I would add 2 to it. If it was, an x one, I would move it to the left or the right. In this case, it is minus 2 on the y. So I need to stay exactly where it is, and then I just go down by 1, 2. And that is literally the answer here. Exactly the same shape, just shifted down by 2. And that becomes easy as soon as you have the classic graph transformations memorized. Mate, an absolute storm has just started outside, but hopefully the mic can picking it up so we can focus on this because we're almost done. So this question looks pretty grim and all, to be honest. It says the point P has coordinates 3, 4, Q has coordinates A, B. Let's get a bit of this down, right? So I got 3, 4. I got A, B, obviously unknowns, right? A line perpendicular to PQ is given by the equation 3x plus 2y equals 7. Find the next expression for B in terms of A. Ugh. Okay, pretty grim. So we don't want B and A. It says expression for B in terms of A. So our answer isn't going to be B is 4. Our answer is going to be B is, I don't know, A plus 3 or something. What is the maths? Like, what is the area of maths that they even want us to do here? Like, how am I going to create this equation, right? So here's the thing. I've got 2 points. So what are some things we can do with 2 points? We can get the midpoint of them. We could get the distance between them. We could get the gradient of them. Are any of those 3 things related to any information that we can get from this? Well, this is a line. We're told it's perpendicular to PQ. So I think this is going to be to do with a gradient. Because remember, if we know that 2 lines are parallel, we know that their gradients multiply together to -1. So if you ever see something like parallel or perpendicular, that should make you think gradient. Like the numerical quantity that's related to perpendicularity in these lines is the gradient, okay? So I suppose my question would be, do we know how to get the gradient of this line? I think we do. Not instantly in this form, but we should be familiar with y equals mx plus c. If we can get this in the form y equals mx plus c, the m is going to be the gradient. So if I rearrange this, I'm going to stick the 3x onto the other side to get 2y equals minus 3x plus 7. Then divide by 2 to get y equals minus 3 over 2x plus 7 over 2. Now I want you to compare it with this red box. What is m in this case? It's going to be minus 3 over 2. Okay, so that's not the gradient of PQ, is it? That is the gradient of this line, which is perpendicular to PQ. So whatever the gradient of PQ is, I don't know. I know that whatever it is, right? So the gradient of PQ, whatever that is, when I multiply that by minus 3 over 2, I must get minus 1 because these 2 gradients are perpendicular. So what I can do is I can actually just solve this equation, can't I? I can cancel a minus, so I get 3 over 2 times whatever the gradient of PQ is equals 1. I can then multiply by 2 and divide by 3. So the gradient of PQ must equal 2 divided by 3. Cool. So this is an important piece of information, and this is what I want to relate to this stuff here, okay? I know 2 coordinates here, 2 sets of coordinates, right? And I know the gradient of the line that joins them. So let's imagine I didn't know that. And then I said to you, give me the gradient of the line that joins these. What would you do? Well, you can get the gradient from 2 points by doing change in y over change in x. So if I was to do the following, right? The gradient of PQ is y2 minus y1 over x2 minus x1. It doesn't matter which way you go. Why don't we do these ones minus these ones? So b minus 4 is the change in y, right? That minus that. Divided by the change in x, which is a minus 3, is the gradient of PQ. But wait a minute, don't we know that the gradient of PQ is 2 over 3? Yes, and that is the connection. So it's like we have these 2 different pieces of information, the coordinates and then that line. We went gradient for both of them, and that is where we get that equality. They both kind of merge together with that common link of the gradient. So this is equal to 2 over 3, and now we're laughing, mate, because all we need to do is rearrange this equation. Times up by a minus 3. This should be sweet for you if you've made it to question 19. So we've got 2/3 times a minus 3. Let's multiply this out. Why not? 2 over 3a and then minus. This is nice. The 3's cancel actually. So 2 over 3 times minus 3 is just minus 2. Add the 4. So b is going to be 2 over 3a. Minus 2 add 4 is just going to be plus 2. And that is going to be my final answer. The rain ain't stopping, but I want to finish this. So the last question says that n is an integer, so a whole number, such that 3n plus 2 is less than or equal to 14, and 6n divided by n squared plus 5 is greater than 1. Okay, find all the possible values of n. The reason we can list the possible values of n is because n has to be an integer. If it wasn't, there would be infinite values, right? So we're probably going to end up with something that's like n is between 2 numbers. That's the dream. And then we can just list the numbers, the whole numbers, in between those 2 numbers. So what we can do is we can simplify both of these inequalities until we hopefully come up with those conditions. The first one looks to be the easy one, right? This is linear. So to be honest, just treat this as an equation, right? Take the 2 from both sides, and I'm going to get 3n is less than or equal to 12. Divide by 3, and I'm going to get n is less than or equal to 4. Good. So that is my first condition, which I'll just put a box around. Second one might be a bit more difficult. The first thing I'm seeing is this fraction, and I would like to get rid of it. So, the natural, I suppose, assumption would be let's multiply by this n squared plus 5. Now, we do have to be careful when we're multiplying or dividing inequalities by numbers, because there's one rule that we need to be careful of. If I multiply or divide an inequality by a negative number, I need to flip it. So that's obvious if I'm dividing by -2. But what if I'm dividing by like x or n or something? It gets a bit more complicated because you don't know what x or n is. What if x or n is negative? So that's tough. If I was to multiply by n squared plus 5 here, can n squared plus 5 be negative? Now, it actually cannot. Why? Because squared numbers are always positive, aren't they? Even if n itself is negative, n squared is going to be positive. I'm then going to add 5, which is obviously just still positive again. So I am definitely allowed to say that 6n is greater than n squared plus 5. In other words, I'm allowed to multiply up by n squared plus 5 because I know 100% that this is positive. Okay, what I can now do is I can kind of turn this into an inequality, into a quadratic, right? Because I've got an n squared term, so it's not simple to just solve it. I'm going to need to get it onto one side with a 0, and then I'm going to have a bit of a chat about how I'm actually going to work this thing out. So this is going to give me the following. N squared minus 6n plus 5 is less than 0. So I'm taking the 6n from both sides. Okay, now this is a quadratic inequality, and I do not see more mistakes in any other topic than quadratic inequalities. Let me show you how not to do this, okay? How not to do this is the following. Is to say, okay, let's factorize this thing. This is what we do with quadratics, right? So I've got, what would I get? If I had -1 and -5, that would work. So -1, -5, and then this thing should be less than 0. Therefore, n minus 1 is less than 0, or n minus 5 is less than 0. So n is less than 1, and n is less than 5. Sweet. What's up with that? Well, first of all, it's a bit weird that we've been given like less than 1 and less than 5, because if it has to be less than 1 and less than 5, then it just has to be less than 1, which renders this whole thing useless. So that's a bit weird. The second thing is just this is not how maths works, right? So it is a good idea to do the factorization. You do need to do this, but which gives us these values, n is 1 and n is 5. But what these are actually called are critical values. In other words, they're like the edge values. They're basically saying, if this was an equation, if this was just an equal 0, these would be the answers. But then we have to think about how quadratics behave. More specifically, how the graph looks, right? So the graph of a quadratic, it's a smiley face or a sad face, isn't it? And that depends on the sign of the n squared term. It's positive, so in this case it's a smiley face. These are useful because these are going to be the points at which it hits the x-axis, so in this case the n-axis, right? So if I've got my axes, I know that it's going to hit them at 1 and 5, okay? So I don't care about doing this super accurate, but essentially the graph is going to look like this. It's going to be a smiley face, and it's going to hit at 1 and 5. Okay. What we have here in green is this thing here, is this left-hand side of this inequality, okay? Now, we want to know when this thing in green is less than 0. In other words, 0 is here, isn't it? Right? Because it's the y-coordinates. These are the y-coordinates that I'm looking at here. So the part for which it is less than 0 is basically this bit down here, isn't it? It's all of this stuff. This stuff here is greater than 0. This stuff here is greater than 0. But everything down here, this stuff, is less than 0. So for what values of n is this green thing underneath the x-axis? It is the values of n that are between 1 and 5. So n is greater than 1 and less than 5 are the values which give this thing less than 0. And that is the important thing here. That is how we do quadratic inequalities. You don't just do a less than all of the time. It's actually greater than one of them and less than the other. Okay, now we've got our two inequalities. I know that n has to be between 1 and 5, and n has to be less than or equal to 4. Okay, so how do I do it? Let's think of a number line. I've got 1, 2, 3, 4, 5. So this green one tells me that I need to be kind of one of these numbers, right? Between 1 and 5, but I can't be equal to them. But the blue one tells me I have to be less than or equal to 4, which again is actually pretty much the same thing, isn't it? It's just anything down here. So what are the values that satisfy both the green and the blue? It's just the values n equals not 1. Completely got that one wrong. It's not the values n equals 1 because the green one doesn't satisfy that. It's the values 2, 3, and 4. And that is the paper. Took us long enough. Hopefully in the next couple of days I will get paper 2 out, which we can use the calculator for. If you want to absolutely smash papers just like this, head on over to AITutor. Every single one of the concepts that I have discussed in this video are explained in detail with a lot of practice and learning for you to do there as well. We are so confident in what it will do for you that we can guarantee you a top grade. If you follow the link in the description or somewhere over here, then you will have much more information about the site.